Hey guys, it's Andrew here again, and in the last couple videos we finished off with VLSM and variable length subnet masks in IPv4 in B and C class addresses. And now we're moving on, we're getting away from that musty old IPv4, that very small networking range, and we're moving on to IPv6, alright? So as you can see here, I've got an example of an IPv6 address, and it's quite a bit larger, right? It's also, we got some letters in here. Now, if you remember way back some videos ago, we looked at hexadecimal and counting in hexadecimal and counting and converting back and forth in hexadecimal and then hexadecimal and in binary, and the conversions back and forth between the two. All right. And now we're actually going to start using in our IP addressing those hexadecimal values. Okay, but this may look big, but trust me, it's actually easier. Believe it or not, I really believe that this is quite a bit simpler. Okay, so some things about this. Again, the structure of the IP address. We're going to only use, so as a rule here, we're only going to use 0 through 9 and A through F, only hexadecimal. But it is not case sensitive. So I got everything written in uppercase letters here, but when you're typing it into a computer, it doesn't matter if it's uppercase, lowercase, it's not case sensitive. It's just hexadecimal. It's either an A or uppercase, lowercase, doesn't matter. Okay? So hexadecimal only. And what we're going to do is we're going to have 8 of these divisions here. Now, we're not using dots anymore, we're using colons, not semicolons, but colons. So 1, 2, 3, 4, 5, 6, 7, 8. And each of these 8, each of these here is referred to as a hextet. Okay, so each of these 8 here, right, any one of these, if I just grab, I don't know, I'll grab this guy here, right? Each and every one of these is one hextet. Okay, and each of them is 16 bits. All right, and each of these guys, each of these values right here, so a 0, an A, a 0, an A, a D, each of those is 4 bits, or a nibble. All right. And remember, if you go back to the prior video when I go over, you know, that the hex table, we were able to convert each value 0 through 9, A through F in binary using only 4 binary values. Okay, so those 4 binary values, each of those, so 4, 4, 4, 4, that is 16 bits total per hextet. All right, because I've got 8 of these. This is IPv6 is a 128-bit address. All right, now this actually works out to in a base 2 system. I believe it's 330 plus undecillion addresses. A lot, big number, right? Also, to give you some perspective. Let's look at the structure of this IPv6 address, all right? All right, so I just moved this up here to clear out the bottom here so we have some room to move. And usually an IPv6 address is broken up into 3 main parts. The first part is the first 3 hextets right here, all right? Draw a dotted line this way, okay? And these guys are called your global routing prefix. Or, as you can see, 163248, your /48, or your first 48 bits of your IPv6 address. Okay? And generally speaking, your ISP, or your internet service provider, or someone, is going to issue a /48. So, just right off the bat, typically you're going to be issued a /48 system. Now, it's not always the case, but typically speaking, this seems to be a common trend right now. You'd be issued a /48. All right, I'm going to skip over this one, and we're going to go to this last 64 over here. This is called the interface ID. All right. And the interface ID is a /64. All right, or 64 bits. 2 raised to the 64th is, roughly speaking, 18 plus quintillion. Okay. Let me make sure I'm spelling this correctly. All right, 18 quintillion addresses. Okay, so what you're looking at here is we have 18 quintillion different combinations in these 4 hextets combined. Okay, and finally, this guy right here. This is the subnet ID. Now in IPv4, we had to manipulate and screw around with and twist and move around our IPv4 address to make our subnets work sort of kind of the way we wanted to, and to try to take a /24 and crunch it down into a 25, a 26, and a 30 to suit our needs. And we had to do all this crazy stuff. In IPv6, we have an entire hextet right here, 16 bits, right? So 2 raised to the 16th is 65,500 and, oh, sorry, 5, that's a 5. Whoop, my bad. Getting ahead of myself. 65,536 addresses, all right? That means one hextet provides us 65,536 combinations, or in our case, given that our ISP or someone would give us this global routing prefix, given this value, we could come up with 65,536 different subnets of our choosing. All right, and this is why I've said IPv6 is so much easier, because it is got a designated hextet just for subnetting. All right, and it's going to be dirt simple to set up subnetting in this. All right, now finally, in the structure here, way over here we have this slash notation. Now you're not going to see subnet masks, but we still need to define what the scope of our network is. So this tells us that the first 64 bits of our IPv6 address, or this block right here, so the global routing prefix plus the subnetting ID or prefix, or whatever you want to call it, is the network portion of our address. So just like IPv4, we'd find the network portion, this becomes the network portion of the address. And this over here, all of this 18 quintillion plus addresses, these are all for our hosts. That means given a single /48 IP address given to you by your ISP or whomever, you can come up with 65,536 combinations, and you'll have up to 18 plus quintillion devices per network. That's insane, right? Where in IPv4, we're just like, oh, can we get like 2 or 5 addresses out of this /29? Oh, look how much I saved. Here we have quintillions of addresses inside of our network that we can just create for all of our different devices. And if we have a couple quadrillion addresses left over, well, who cares? All right. So again, this just gives you the sheer scope that we're dealing with. 330 undecillion. I don't have it in my notes right now. I want to say it's like 330 plus 30 something zeros, like 36 or 35, something like that. Some ridiculous number of addresses in a 128-bit system. Okay. So again, this is the structure of this address. All right. So again, following these 2 rules, again, under the structure, we can have 8 hextets here, 16 bits each, and they can be in hexadecimal 0 through 9, A through F. All right, and we're going to be following this structure. We're going to have a global routing prefix. Typically, it's going to be given to you. You might sometimes get like a /16 or even a /8. Very rare though. But generally /48 in the global routing prefix. You have a dedicated subnet ID. Now, before I get ahead of myself, there is a technique called subnetting on the nibble, where you can like subnet over here into the interface ID. You can do it, but with this many, with 65,000 plus subnets per /48, it turns into a why bother, right? But you can do it. It is something. You may hear about it in the future, where you can subnet into the interface ID, and you can create like /127s, /126. You can create really small point-to-point networks, but that's quite a bit more advanced. I mean, again, within the scope of these courses here, I don't really expect you guys to be needing to do that, but you know, it's something that you can pursue in the future on your own. I'm not going to cover that in these videos here. Okay, so in the next video, we're going to talk about how you can trim this address down, because this is quite large. So we have two of our Rule 3 and Rule 4, which we're going to go over in a little more depth. So I'll see you guys in the next video when we take this and we crunch this down and we make it a little more easy to work with.